Hello, everyone. This is my presentation on fire as an evolutionary mechanism in pine trees. My name is Miriam Seeley, and I am quite sick today, so I hope you'll all forgive me if my voice sounds not the greatest. So, when we think of wildfire, many of us often immediately think of something negative, which is understandable because humans have not often had an especially good relationship with wildfire. It's whether that fire is naturally occurring, such as like a lightning strike, or whether it's artificial. Today, around 80% of all wildfires are caused by people. And a lot of these wildfires bring a lot of devastation and they destroy a lot of homes and they cause a lot of issues, economically speaking. And so, a lot of times we think of wildfire as an inherently bad thing, but historically, wildfire has actually been an absolutely pivotal component of the evolution of many different species, not just pine trees. But we have seen evidence of how it has influenced many ungulate species, such as like this moose, elk, deer, those kinds of things. We've seen how it's influenced grass, flowers. But today we're just going to be focusing on pine trees. Um, and we have seen evidence that not only does fire have a vague influence, I mean, of course it does, it's a biogeographical factor, just like climate or precipitation, but it isn't just an influence, it also can be a selective agent in that it can essentially choose, if you will, certain traits. Now, of course, fire doesn't choose, fire is not alive. But we see that in areas that experience certain kinds of fire, we see certain kinds of traits. And that's where we get this idea of a fire regime. If you think of a regime as like an area that's controlled by one thing, like a kingdom, right, or an empire. So a fire regime is an area where that experiences a certain kind of fire. For example, an area that has a lot of surface fires where the fire is fairly close to the ground is going to be very different than an area that experiences a lot of crown fires where the fire is higher up in the trees. And because of those differences, we see different traits because the trees in the area would have to respond differently. So today we're going to be kind of exploring the differences in some of those traits and the differences in those fire regimes and the resulting fire adaptive systems. So my thesis is mostly talking about the Pinus and Strobus subgenera. And both of those genera, plural genus, are underneath the Pinus genus, which is under the family of Pinaceae. And so, but this is all talking about pine trees because there's a lot of different kinds of pine trees that grow in different areas, and those different areas have those different fire regimes. So we see very different fire response systems. For example, in the Pinus genus, which we'll talk about a little bit more in a minute here, we see that they have evolved in more productive, highly fire-prone areas, and they've developed very complex fire response systems, whereas the Strobus genus has spread out through areas of greater environmental stress, but less fire, and we'll talk about that in a moment. So, how long has fire been a component of the evolution of pine trees? Well, we have evidence that says that pine trees have been evolving for around 237 million years. However, we only start to see these what we are known as these fire response traits around 126 million years ago. So we've had that really large stretch of time where we don't see what we currently think of those fire adapted traits. Some fossil evidence from the Cretaceous period suggests that wildfire was common. So we see, and we think that's likely due to the higher oxygen concentration in the atmosphere. It was quite a bit higher then than it is today. And the reading I read talked a lot about why we think that wildfire was more common back then. But the point is, when you see this environmental factor of fire, when that becomes more and more common, of course, we're going to see more and more traits that are associated with that. And so let's talk about some of those traits. 2001, we have Schwilk and Ackerley. They've done quite a few studies. I mean, several of the papers I read were all about their various studies on wildfire traits. And this circular graph here might be a little different to interpret, but basically the way it works is that these top three, this bark thickness, serotiny, and self-pruning, we'll talk about what those are in a second, but those three are what we call anchor traits. And that means these are our known fire adapted traits. So what they were trying to say is like, okay, we have these known fire adapted traits. We want to see if these are correlated with any other traits. That is, did they co-evolve? What's the influence there? Their goal was to see if fire itself had, quote, selected for correlated evolution among alternative suites of traits in pines. Basically, we're saying, well, there's all these traits that pine trees have. How many of them were actually influenced by fire? So if you look at this circle here, the thick lines are as a positive correlation and the thin lines is a negative correlation. So if we look here at serotiny, here at the top of the circle, that has a dashed line as well as several dashed lines, some of which go to minimum reproductive age, which is a trait. We also see serotiny it has a negative correlation with leaf length. And then if you look to the left of serotiny, we've got bark thickness that's got several positive correlations. So what they're showing here is that they did see correlations between these known fire traits and other traits that a pine tree has. And what that tends to indicate is that yes, fire does have an impact on the traits that a pine tree will evolve, because we see that it does have that correlation between other traits and then fire-related traits. So I mentioned serotiny just a second ago, and that's one of the most interesting fire adapted traits that we see in pine trees. And what serotiny basically is you have a pine cone, right? And pine cones, when they're on the tree, they're closed. And some trees, they open up by themselves. Others, those pine cones have to be opened by birds, which is where we get indehiscent cones, which is right there on the slide. And then some trees their pine cones can actually only be opened by fire itself, that they secrete this very thick tar-like substance that only melts at very high temperatures that they would not see in a hot summer. No, it would need to be an actual wildfire. So what we see is that serotinous pine cones only germinate after a wildfire event. And that's very interesting because it's a little counterintuitive. You would think, well, why would a tree want its cones to get lit on fire? Well, it's just one of those fire adapted traits, because in trees that exhibit serotiny, what they're doing is they are exhibiting what we call the fire embracer syndrome. And a fire syndrome is a series of traits that a tree will use to adapt to fire. And what they're doing is they're basically using that fire to their advantage, because although the adult trees may die in the fire, now they have all these pine cones that are sealed and protected until the wildfire event. And then that's when they open. And then immediately after the event, now you have a whole bunch of pine cones that now have this opportunity for germination. And so basically you have a species, an entire population that can more easily survive a wildfire event because of this serotinous pine cone. So we see serotinous pine cones in fire regimes that experience very frequent surface fires, that is, fires that are closer to the ground. We definitely see that in the Pinus genus. Now, I don't really have time to go over all of these in depth, but thick basal bark is a fairly simple concept. Basically, the bark that's further down on the tree that's closer to the ground is thicker, because it insulates heat really well, and that way it's less likely to die in the fire if that's it. Self-pruning is fairly simple as well. Basically, it's where a tree will remove its own lowest branches so that the fire is not as able to climb up into the canopy of the tree. And I mentioned indehiscent cones. Those are ones that can only be opened by birds. So the first three traits I mentioned are what we see in pinus trees, but indehiscent cones we actually see in strobus trees, which is that other genus that I mentioned earlier, because those don't see fire as often. So having a pine cone opened by fire would not be useful to them. So we actually see pine cones opened by birds. It's a very different trait that we see in areas that have a lot less fire. So I already mentioned that this fire embracer syndrome that we see in Pinus, but there are actually two other syndromes. There's the fire tolerator and fire refuge, which are also systems by which Pinus trees will adapt to frequent fire. Because that is a major difference we see between Pinus and Strobus, is that Pinus trees have these consistent wildfire events, which are now far more consistent than they have been historically because of human interactions. But then we have the fire syndromes in strobus trees, and the main syndrome we see is the fire avoider syndrome, which is exactly what it sounds like. It means that that tree is avoiding the fire, that they tend to live in these environments that don't experience frequent wildfires, which often are very harsh conditions. I really like this picture because you can see that that tree is not living in a place that trees normally live, but that's because their species has evolved to be further away from fire, as opposed to embracing the wildfire events they've chosen to, well, not chosen, animals don't choose, but you guys know what I mean, that they're avoiding it entirely. And so I listed a few examples of that syndrome there. And so we see that just in these two subgenera, Pinus and Strobus, we have very different means of adapting to a fire response. And they've evolved them in very, very different ways, and even at different times. And that just tends to indicate that they cannot be managed in the same way. And I also don't have time to talk about this in depth, but I think that it's very important to understand the evolutionary history of fire, because in the past, when we've fought wildfire, we've just done this blanket method of let's just put all of the fires out. Let's just suppress every single one. But the problem with that is that, mentioning the serotinous pine cones earlier, that pine tree has evolved for frequent fire. So if you put out all of the fires, you're actually interrupting that biological process. And so when we understand that history, when we look at the phylogeny of these trees, we can understand that different fire regimes that have different fire syndromes need different management plans. And so that's just something that I think is very important. And I think that when we take into account the evolutionary history and those different adaptations, that we can improve the way we manage wildfire. So that is my presentation, and those are my references. Thanks for listening.